Okay, welcome to everybody to this session. Perhaps some others will join, but we cannot be later than this. I am in charge of chairing this session, which will be held in a slightly different way from the previous one, in the sense that health and safety is something which goes across all nanotechnologies. And therefore, I think it is very important to give the message of what are the major issues, health issues, when dealing with nanotechnologies. I will start by saying few words on this topic, on the main issues, and then we will go on mainly discussing the issues, and not so much our own projects. Now, the health effects of nanotechnologies are really we can see them from 2 points of view. One is what we have just heard, the outstanding new tools which we have in nanomedicine. The other one are the deleterious health effect upon exposure to nanoparticles. Now, also engineered nanoparticles may be toxic. We certainly know that in air pollution, nanoparticles are one of the most toxic components, but also engineered nanoparticles may be toxic. Toxic for workers, first of all, users, and for the environment. Now, this alarm was raised by the scientific community more or less at the beginning of the century, but immediately joined the media in various ways, and the outcome was that people thought that all nanoparticles are dangerous just because of their nanosize, no matter their chemical composition, shape, or whatsoever. Now, this is not true. And the scientific community, in the meanwhile, is struggling to find out which are toxic and which are not. We have a new discipline term, nanotoxicology, several meetings, workshops, etc., wanting to put on sound chemical and biological basis this alarm, which is a correct alarm, but is not yet on sound basis. And finally, a new journal is launched, Nanotoxicology, which only deals with the toxicology of nanomaterials. Now, in this discipline too, the number of published papers dramatically increases. You can see it from this slide, and you can easily understand that it's very difficult, even for us who are mainly working on this topic, to know all what is in the press. Every day we have a new paper, more or less. The awareness of the hazard associated to nanoparticles is really quite widespread, also among the agencies, among people who give fundings for research, etc. And however, in spite of all this publication, for the moment being, the toxicity mechanism, talking at the molecular level, why this particular nanoparticle is much more toxic than another, are not yet known. The correct planning of the experimental research also requires some adjustment, as we will see later on. And finally, in spite of a remarkable toxicity to cells and animals of some nanoparticles, we don't have yet any pathology associated to nanoparticles. We know very well the pathologies associated to asbestos, to silica, to other compounds. For the moment being, we do not have pathologies. Therefore, nanotoxicology is a very important discipline. Nanopathology doesn't yet exist for the moment being, and we hope with nanotoxicology to avoid any nanopathology to occur, which means do not do what as it was done with asbestos, but prevent the risk as soon as you can. Then, as you see, several particles can really be dangerous, and carbon nanotubes are one of the typical examples. We have many, many evidence now that carbon nanoparticles are not inert, and in some cases, they can give rise to adverse effects. Moreover, there are some papers explaining that there are some similarity between carbon nanotubes and asbestos, which is true, and some also seems to indicate the possibility of the same kind of pathologies caused by asbestos, but this has still to be verified and confirmed. Now, we have anyway some general consensus. One is that not all nanosized particles are toxic, because toxicity is related to many, many other features. That nanoparticles offer a new scenario from their larger counterparts, talking about very, very small particle or a bigger one. And finally, that there is a requirement for new and widely accessible tools to screen all the new particles, because we cannot think that they can all be tested in vivo. So we need a good way to screen these particles. Now, what are the main features of this new scenario? Obviously, the nano size, the higher ratio of surface to bulk atoms, which enhance any surface effect, a strong interparticle forces, and in some cases, typically nanodots, specific properties at a nano level. Nano size implies different cell responses, different way of translocation through biological compartments, other penetration routes, which means that we have many other target organs beside the lung, as we have with bigger particles. Just to give you an idea, this is a general scheme of what happens when a particle is inhaled and when the immune system tries to get rid of the particle, very often it cannot do it. With nanoparticles, we have much more reaction before this whole story of the immune system, and also after, because nanoparticles are uptaken much less than bigger particles, but then they are there to give rise to toxic effect on target cells. But what is worse, the typical thing of nanoparticles, is that they can penetrate and go into the bloodstream, and so virtually in many, many other compartments. And in fact, it was seen that some nanoparticles on experimental animals attain the brain. Some may penetrate through the skin, so this nano size already makes a big difference between bigger and smaller particles. Then we have the surface effect, very high surface area, an enhanced surface activity, which means enhanced capability of releasing free radicals and other deleterious reactions. Strong interparticle forces, which means strong aggregation of particles, and so we really have difficulties in finding out what is the real dose, because of the high surface area and of this in strong interparticle forces. Very often we administer to cells, to animals, something which is not yet no more a nanoparticle, which is an agglomerate, aggregate, and so on. And this has absolutely to be masterized, which is not yet. And finally, as I was saying, nanodots, for instance, offer a quite different activity when they are in such a small size. One of the major unresolved problems, I suppose the other speakers will confirm that, is the definition of an appropriate metric for doses and human exposures. Dosimetry is very difficult, and in fact we have even had people proposing the oxidant properties, which is one of the deleterious properties, not all, as a possible way of dosimetry. This, from our point of view, is a bit limited, but gives you the idea of how difficult it is to find out a good dose. Now, what we will be talking today, we have 3 talks. The first one will be given by Professor Bergamaschi, and this will be mainly dealing from a medical point of view on hazard and risk. The second one will be given by Dr. Fenoglio, and we will here see the opposite side of the story, the relevance of the physicochemical properties. And finally, Dr. Riediker, who came to us from Switzerland and who has set up a nano-impact net, a very good and useful net to make all people in contact when necessary. He will talk about this net and a healthier future. Just one thing to say, in this field we strongly require a multidisciplinary approach. All these disciplines require not to be used but to be discussed all together. Otherwise we won't find out much of what is necessary. Now I would like to say that in the University of Torino we have the tools to have such a multidisciplinary approach. We have an interdepartmental center for the study of asbestos and other toxic particulate, with which we have dealt rather successfully with bigger particles. When it comes to smaller particles, luckily we have another center with whom it's possible to collaborate between the centers, which is the Center of Excellence for Nanostructured Surfaces and Interfaces, which, of course, may give all the information required on the surface. Those of you who are interested in these two centers and the project, etc., will find it in the stand of the University of Torino and can take these two leaflets which illustrate the activity of the two centers. Well, now I think I will pass the microphone to Dr. Bergamaschi, who will explain to us all about hazard and risk. Please, Enrico.